Hi, welcome to my video on basic integration rules. This video will go through all the main integration rules you need to know with some examples. So watch closely and follow the techniques. Now when integrating, it's very important to remember this key point. The integration process is the opposite of the differentiation process. So it means that everything you learned of how to differentiate different functions, you are now going to do the complete opposite. Now this has two main implications to your work. The first one is that when you've done a question on integration, you can always check your answer by differentiating the question, differentiating your answer, and it should go back to the original question. Now the second thing is when we did all the differentiation techniques, they always involved multiply. Now since this is the reverse technique, these all involve dividing. I need to remember that whenever you're doing an integration question. Right, so first of all, integrating polynomials. So polynomials are when it's something like y equals 4x squared or 3x cubed or something like that. So remember, integration is the opposite of differentiation. So this time, instead of multiplying the power by the number in front and reducing the power, we need to increase the power of x and then divide by the new power. That's the rule. So we have, if y equals a x to the n, then the integral is going to be a x to the n plus 1 and then divided by n plus 1. And then we mustn't forget to put a plus c on the end. So here's some examples. The first one, y equals 5x squared minus 6x plus 9. So when we integrate this, we look at the first term, it says 5x squared. It's going to become 5x cubed because we've increased the power by 1. But we've also got to divide this whole thing by 3, which is the new power. So we get 5x cubed over 3. The minus 6x is going to become minus 6x squared over 2. And the 9 is going to become, not going to disappear like it did with differentiating. It's going to become 9x. And we've got to always remember that numbers that did disappear when we differentiated must reappear, and so we must always remember to put a plus c on the end. Now when you've done an integration question, it's always worth just looking through, is there anything I can just simplify here? Now if you look at the second term, we've got a 6x squared divided by 2, and 6 divided by 2 is just 3. So we can simplify this and leave it as 3x squared instead of 6x squared over 2. Let's look at the second example. It's a bit more difficult. We've got 3/4 x squared plus x over 9, or 9th x, minus 12 over 7. So we look at the first term, and we've got to increase the power of x, so it becomes 3/4 x cubed over 3. We'll simplify that in a moment. The 9th x is going to become a 9th x squared over 2. And the minus 12 over 7 is going to become minus 12 over 7x. And we've got to remember the plus c. So again, now we need to simplify this. We've got 3/4 and we've also got a divided by 3. Now if you're dividing something by two different numbers, those two numbers can be multiplied together. So the 4 and the 3 at the bottom of that fraction, they become 12. 3 over 12 is just a quarter. The second term, the 9th x squared over 2, we've got a 9 and a 2 on the bottom, which means we've got an 18 on the bottom. So let's just simplify that and show that correctly. So it's a quarter x cubed, or x cubed over 4. And we've got an 18th x squared, or x squared over 18. That's how you integrate polynomials. So next we're going to integrate trigonometric functions. That means integrating sine and cosine. Again, remember that integration is the opposite of differentiation. When we differentiated, we had to change sine to cos, and cos became minus sine. So we're doing the reverse. So integrating, we have to change cos to become sine, and sine becomes minus cos. When we differentiated, we multiplied the number in front. This time we're going to divide the number in front. So there's the rule for sine. Sine becomes minus cos. and there's the rule for cos, and it becomes sine. So let's look at a couple of examples here. The first one here, y equals 5 sine 3x plus 7 cos 2x. So sine is going to become minus cos. So I've just put the minus cos 3x there. I've left a little gap because I've now got to do that little division sum. Now it's a fairly easy one here. It's just 5 divided by 3. But sometimes it can be more complicated, especially when you've got fractions involved. So we're going to now insert the 5 over 3. Look at the next term. So plus 7 cos 2x. So cos becomes sine. So it's going to become plus something sine 2x. Again, I've left a little gap. I'm now going to get that number correct. And we just got to divide the 7 by the 2. So it just becomes 7 over 2. And don't forget the plus c. Again, check, is there anything you can simplify in those fractions? In this particular case, there isn't anything I can simplify, so that is the final answer for that question. Let's look at the other example. It's a slightly more difficult one. So, first of all, we've got 11 over 4 sine 3x over 2. Sine becomes minus cos, so I'm just going to put in the minus. I'll leave a little gap, and then put cos 3x over 2. I now need to think about that number that I've got to put in there. I've got to divide 11 over 4 by 3 over 2. Now 11 over 4 divided by 3 over 2, I'm going to have to flip the second fraction upside down and then multiply. You get 22 over 12. Look at the second term now. 5/6 cos x over 5. So cos becomes sine, so I can just leave a little gap, and I'll just do the sine x over 5. And I've now got to get that number right, so I've got to divide 5/6 by, and that's 1/5 in that bracket, so 5/6 divided by 1/5. So you flip the second one upside down, and we get 25 over 6. And that's that term done. And then we need the plus c. Now, is there anything I can simplify there? And this time there is. If I look at that first term, 22 over 12, you don't normally write 22 over 12. You could write that as 11 over 6. So I've just changed that to 11 over 6 just to make it neater and to finish it off properly. And that's how you integrate trigonometric functions. Finally, we need to integrate exponential functions. Again, remember that integration is the opposite of differentiation. When we differentiated exponential function, we just had to multiply the number in front by the power, the number in the power, but everything else stayed the same. So this time, when we're integrating exponentials, we need to divide the number in front by the number in the power, and everything else remains the same, except we must remember to put the plus c at the end. So the basic rule is shown there. If y equals b e to the ax, we've just got to divide that b by the a, and the rest of it stays the same. Here's some examples. So the first one, y equals 5e to the 4x. So the e to the 4x is all going to stay exactly the same. We've only got to divide the number in front by the number in the power. So the 5 divided by the 4, 5 over 4. And we must remember the plus c. And that's that one. That's that easy. Let's look at the second one. So we've got 15 over 4 e to the x over 6. So the e to the x over 6 stays the same. The number in front, we've got to divide 15 over 4 by 1/6. So I've just written it there, 15 divided over 4 divided by 1/6. And we don't forget we need the plus c. I'm now going to work that out. 15 over 4 divided by 1/6. You flip the second one upside down and multiply. So it's 15 times 6 on the top, which gives you 90 divided by 4. And 90 divided by 4 can be simplified, in which case we get 45 over 2. Okay, and that's how you integrate exponential functions. So these are all the rules I guess when you're doing integration techniques, the most important thing to remember is that integration is the opposite of differentiation. You always need a plus C in here, but you can check all your work by just, once you've done the question, you can just redifferentiate it and just see whether it goes back to the original question. That's it. Thank you.